Give a little bit, give a little bit of your time to me. Give a little bit, give a little bit of my time for you. There's so much that we need to share, so take some time and show you care. Hey everybody, welcome to this week's edition of Video Notes for Mr. Flugum's General Chemistry class. That's right, this is for General Chemistry. And for your pleasure, this is going to go on page number 21 in your science notebook. Now there's a lot of information here, folks, so I want you to try and fit this all on page 21. Try and keep your notes kind of close together and grouped as far as groups on the periodic table, because that's what we're talking about. Thanks for tuning in. Let's get started. So let's start out by talking about this idea. Where did the periodic table come from? Well, basically the idea kind of originated with this guy right here. His name was Dmitri Mendeleev. And he gets the idea, or the credit, excuse me, with inventing the periodic table. So this right here, you see here, this is kind of his original periodic table. Okay, it looks nothing like the one that we have now, but this was the beginnings over 100 years ago, right? And he came up with the first idea of grouping elements based on their common characteristics. So here we have a look at our modern periodic table. Again, you can see that things are shaded in different groups, right? We're going to talk about each of those groups very quickly in this short PowerPoint, and I want you to take notes so you know which group is which. All right, remember this, folks. Elements are arranged vertically. That means up and down into groups, right? So groups are up and down. There's 18 of them. I had you number them on your periodic table. And then they are organized horizontally, right, side to side, into what we call periods, of which there are, I believe, 7. So one of the reasons the periodic table is shaped the way it is because it's divided into several families based on groups, right? Remember, the groups go up and down, right? The columns on the periodic table. So we're going to talk about several of those groups here, where they are and what their characteristics are. So here's our first group, our first family. It's called the alkali metals, right? And it is group 1 on the periodic table except for hydrogen. Hydrogen's kind of like the black sheep of the periodic table. These are our friends like sodium, right? Potassium, things like that are really exciting and highly reactive. It's fun to put them in water. Who knows, maybe we'll do that. Now, because they are very reactive, we never find them in nature in their pure form. So here's our second family we're talking about, group 2, the alkaline earth metals. So these are all very similar in appearance, and they're fairly reactive. Not as reactive as the first group, the alkali metals, but most of them will react with water and the air. And we call them the alkali earth metals because, well, they're found in many rocks here on Earth's crust. So one of the cool things about the alkaline earth metals is what we use them for. They tend to have very bright colors when they burn. So for example, strontium gives you nice reds, okay? Barium gives you good yellows and greens. Magnesium has those very bright white ones, and calcium is a nice orange color. Now radium's kind of cool because you don't have to light it on fire to get it to glow. It does that on its own because it's radioactive. Okay, this big block in the middle here, groups 3 through 12, we're going to call those the transition metals. Okay, these are our typical metals that we're used to. Copper, iron, zinc, gold and silver fall into this, as well as mercury and other very useful metals that we use all the time. One of the great things about them is they're malleable. They're very easy to bend and shape. So the next group we'll talk about is the poor metals. These are metals that just are much weaker than the transition metals, even though they share many of the similar properties. For example, being good conductors of electricity, they tend to be kind of weaker and softer, and also have lower melting points. These might be things like lead and tin, right? Also, aluminum falls in there. Although these are very useful metals for us. All right, let's talk about the metalloids. So the metalloids lie along this stair-step line right here that starts at boron and works its way all the way down to astatine, which is element 85. Metals that border that, except for aluminum, that border that line tend to be what are called metalloids. So they are kind of these in-between elements. They share properties of metals that we've talked about. They're shiny, okay? They are somewhat good conductors of electricity, okay? But they also share some properties with nonmetals, which we'll talk about in just a second. Okay, next we have the nonmetals. These are metals, these are elements that tend to be brittle, at least when they're in their solid form. They do not conduct electricity, right? So they're non-conductive, good insulators, and a lot of them tend to be gases, right, around room temperature. For example, oxygen and nitrogen, okay? This group here called the halogens, which is group number 17, okay? They are also nonmetals, we said, so they share those properties, and they tend to be gases for the most part. They are poisonous to us, at least in large quantities, and they tend to be fairly reactive elements, right? For example, fluorine is extremely reactive, as is chlorine, and bromine is as well. Although bromine tends to be a liquid, and iodine is a solid at room temperature. All right, and our second, well, not really the last group, but the last group on the upper part of the periodic table we'll talk about is the noble gases. And we'll talk about why they're called noble gases a little later, but basically these are unreactive elements, so they don't react or form compounds very easily. They're nonmetals, just like all the other elements on this side of the periodic table. And of course, since they're gases at room temperature. They tend to have very, very low freezing points as well in order to make them solid, or even to get them to be a liquid, you have to get them very cold. All right, now let's move down to the bottom of the periodic table here. Those two they look like periods or rows down at the bottom. Remember, those belong up here in these boxes right around here. The lanthanide and actinide series, right here is where they belong, and we took them out to make the periodic table not so long, right? So the lanthanide series, right, these are called the rare earth elements. So not because they're extremely rare, but they are hard to find and isolate here on Earth, okay, but you can find them in the Earth's crust, and they are shiny and tend to be fairly reactive, right? But they're all very similar in their properties, so it's hard to tell them apart. Okay, last slide here, folks. Let's be talking about the actinide series, which is the very bottom row down here. Okay, now these tend to be all radioactive elements, and they include such famous ones as uranium, right here, which is U, plutonium, and other elements that are used in making atomic bombs and so forth. Right? Now, here's something interesting about them. Elements 95 to 103, so starting here at americium and going on up, these are not naturally occurring elements. They don't happen in nature. They're actually made in nuclear reactors and for research purposes. So, yeah, they really are man-made. Well, thanks for tuning in, folks. I appreciate your time, and thanks for taking notes. We'll be talking about this stuff in class on Wednesday and Thursday. Have a great day. Bye-bye.